In this lesson, we're going to take a look at 2 points on a coordinate grid and finding the distance, the straight line distance between them. And this comes into play into a lot in the real world with surveying and blueprints, etc. So here's what I'm going to do. I'm going to zoom in. And what you have to understand is I have two ordered pairs, -8, 5, 8 left, 5 up, and -2, -3, 2 left, 3 down. So you're going to have this on IXL when you do it, but in theory, you would get graph paper, and then basically you would be connecting your lines to them, and you get your right triangle. So now the question becomes, what are my A and B measurements? A couple ways you can do this. One, you can literally use the graph. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So you can actually count down the side. So that triangle is 8 vertical, up and down. Or you could use, if you think about XY, ordered pairs, which number in my ordered pair gives me my vertical alignment? It would be this. So you could literally figure out how far it is from +5 to -3. That'd be a straight distance of 8. Either way works. Same now with the vertical. With the horizontal. So how wide across is my triangle? 1, 2, 3, 4, 5, 6. I could have also gone from my x values, -8 to -2. So you're dealing with the triangle, that's 8 and 6. Remember, those are my legs. So what we're trying to figure out is what your hypotenuse is, or C. Now, you could do a squared plus b squared equals c squared, or you can go back to your Excel and find the part of your Excel that has the 2 legs and it solves for the hypotenuse. So I'm going to put in 8 and 6 on my Excel, hit enter, and I get 10 as an answer. So my answer would be 10. So from this ordered pair here to this ordered pair here is a straight distance of 10. So let's take a look at another problem, and I'm just going to zoom in here. Again, basically we're dealing with right triangles, so what I'm going to do is connect my ordered pairs so that I can make my right triangle. And my vertical distance, I'm looking at the y values. Okay, it's 6 up here and 10 down here. That gives me a total distance of 16. So one leg is 16. And then to find my other leg, I look at the x values, and it's 4 on this side and 8 on this side, which gives me a total distance of 12. So you're dealing with 16 and 12. So I'm going to go back to my Excel. 12 and 16. And that gives me a hypotenuse distance of 20. So the biggest thing with this lesson is being able to visually form the right triangle and then literally figuring out what are your leg sides. Figuring out your legs, typing it in your Excel calculator, and figuring out what your hypotenuse is. Let's try one more. We'll go just a little faster. Here are my 2 ordered pairs. I am going to draw in my right triangle. There's my right angle. So I'm trying to now figure out what one of the legs is. Up and down, it's 3 on that side and 9 on this side, so that gives me a total of 12 up and down. And horizontally, again, I could count 1, 2, 3, 4, 5, 6, 7, 8, 9. I could count across, or I could just say, oh, well, there's a 10, there's a 1, so from 1 to 10 is a difference of 9. So I have a 9 on one side, a 12 on the other. Go to my Excel, put in 9 put in 12, hit enter, and that gives me c equals 15. Okay? So again, just another real life time where you use the Pythagorean theorem. It's very common in surveying and things like this where you have, you're looking at a bigger map or a blueprint where you have from one point to another point, find the vertical distance between the points, find the horizontal distance between the points, use Pythagorean theorem, and then you get the straight line distance from one point to the other. All right, good luck.